So let's just a warm up and kind of extra help on just thinking transformationally. Let's do, this is one of the harder ones in the book. Let's say I've got the line y equals mx plus b. There will actually be a little bonus associated with this. So that means I've got intercept b, and right now, I'm thinking of this as just the normal plane. I'm not thinking about complex things right here, just a line in the normal plane. And then this intercept here would be negative b over m, good old line. So what we want to do is find a formula that if this is a line in the complex plane, now we know that we can, this isn't what our normal lines look like, right? They're gonna look like this. We would have to make that conversion over to here. But what we're gonna do is assume that we have this form of the line, this is in C. I wanna find the formula for reflecting over that line. So T of Z is on the other side. If, in other words, if you just folded the plane along that line, where would the dot hit? So this is a harder one. I want to do this together so you can see a few of the thought processes involved. First off, does this make sense, what I'm doing? Kind of, definitely, we want to make sure we understand what the question is, right? Cool. So, let's think about what we have. We know we have, this is our flip, this is rotation by theta. So let's just kind of put up our dictionary here, our tool set. Rotation by theta about the origin. Really important. If I take Z and I add something to it, a K, this is shifting. So this is a translation or a shift. Now here I'm assuming this K is actually a complex number. So let's say it's K sub R plus K sub I times I. I'm just saying that particular form. So this is a horizontal shift. The real part is horizontal shift. If it's minus, it's to the left. If it's plus, it's to the right. And this is the vertical shift, or translation. And then we've got one more thing, and that is if I take R times Z, that is scaling. If R is bigger than 1, it's expansion. If R is less than 1, it's shrink or contract. Does that all sound vaguely right? Okay, cool. So let's get on that thing right now. The way to think of these translations is to move the object that you are reflecting over into a more standard position. So right now, I don't know how to reflect over an arbitrary line just floating in space, but if I get it at least touching 0, I have a chance. So my first step is to move this line with translation either down B units or to the right B over M units. Does that make sense? So first step is translate. And let's do that. I'm gonna go down just because it's less to keep track of. So step 1 is translate translate the line to the origin so that it passes through the origin. And this is done by shift down B units. But I want to be really careful with this. This isn't the complex plane, so I'm actually going to, oh, we didn't do mindfulness. Oh well, okay, that's all right, it's too late. So this means I'm going to subtract BI. And B is just going to be a real number. So B is real. And it's just how many I's I'm going to move down. So my first step is to take Z minus BI. whenever this b is here, because the I isn't attached, right? The way I've written it here, the I is just unspoken. There's an I on that. So that shifts me down. So now, at this point, here's where we're at. Let's draw each step of the way. So I've taken that line. It still has slope m. But now we're at the origin, and then that z also kind of shifted similarly. So there's z minus bi right there. What should we do next? What do you think? Any ideas? Lou, I don't know if you're raising your hand or yeah.
Could you like rotate it so that the line turns like flat, so it's like the x-axis?
Absolutely. Let's just rotate that so that it becomes the x-axis. Perfect. So how much do I rotate it? Well, let's put it theta for a second, and then we'll figure that out. So we're going to rotate this by theta clockwise. So that is times e to the negative I theta, right? Because, so this is positive. So let me actually say this. So if I have e to the I times a positive number, this is clockwise rotate, counterclockwise rotation. So that's rotation this way. If I have e to a negative times I, that's clockwise rotation. So I'm going to put negative theta here because I'm assuming that's a positive measure. And so what I would get is this. We'll worry about, like I said, theta in a minute. So there's step 2. And then what? So now we're at, let's look at where we're at. We've just rotated by theta, so we're here. And then our z is here, and we've got e to the, this should say negative theta, sorry. E to the negative I theta, z minus bi. What do I do now?
Is this where you use the conjugate?
Yeah, perfect. That's how I flip. Awesome. So now I'm going to take the conjugate of where I'm at, and it will flip us over. So step 3 is take the conjugate. Nice. And that's going to flip it over. So this is e to the negative I theta, z minus bi, conjugate. Cool. Now what? We have to get back to that original situation. The line didn't look like this. What should we do to that line?
Reverse steps 2 and 1.
He said, yeah, totally, yeah. So now rotate back to the appropriate angle. So step 4 is now rotate back by theta. So this time it's going to be counterclockwise. So what I do here is I've got e to the I theta times, be really careful with what is what and what's being conjugated. And we'll clean it all up, but let's just write things as we go through. So now I'm rotated back, so now I'm here. And what's the last step? Translate back up. And then lastly, translate or shift back up b units. So that's just a plus bi now. So I'm going to take this, and I'm done, pretty much. My transformation is now defined as e to the I theta, e to the minus I theta, z minus bi, all that conjugated, plus BI. And let's clean that up, because that works, but I bet it's prettier than that. So let's do a couple of things here. Let's work through this together. That e to the I theta is out front. What is the conjugate of e to the negative I theta? E to the positive I theta. Can you picture that? Let's picture that a couple of ways. So if here is e to the negative I theta, what is its conjugate? Well, that just means that's negative theta. So the conjugate is just a positive theta. So I can picture it that way. So this conjugate is just e to the I theta. Cool. And then this conjugate, it just goes everywhere you would want it to. So you can think of it as distributing it. So it's z conjugate minus bi conjugate plus bi. Looking better. What is the conjugate of bi? What is it? I'm sorry.
Negative BI.
Negative BI. So you can either think of this as what is the conjugate of negative BI or what is the conjugate of BI negated. But if you think about it, here's BI, or here's negative BI. Positive BI is its conjugate. Just flip it right over. So this thing here is going to become e to the I theta, e to the I theta, z conjugate, can't do nothing with that, but this becomes plus bi, plus bi. And then lastly, what I'm going to do is just kind of plow through and get it into something z plus something z conjugate plus a constant. So we go all the way through. We've got e to the 2I theta, z conjugate. So that's this all together. But then I have these two times this as well, plus this dude out here. So this is going to be, my constant term is going to be the original bi that's here, that thing, plus e to the 2I theta bi, and that's kind of all my constant stuff. And you could pull the bi out if you wanted, but hell, we got a good form right now. When you make these transformations, test out how well you did. So for example, let's say the line looked like this. Let's just test a really simple one. Let's just say it's y equals x. And so theta is just 45 degrees and b equals 0. Let's just see if this works. You know, so you come up with a formula, test it on something easy. If I take the point 1 in, it better turn into I. That's the flip over that line. So let's just see if that actually works. So our formula, in this case, with theta is 45, b is 1, is going to look like this. T of z equals e to the, and this should be pi over 4, right? Pi over 2i, because it's twice that. Z conjugate plus dead. Cool. Awesome. There is nothing else to the formula. What is e to the pi over 2i in a nicer form? I. So it looks like our formula works. So this formula, to flip over y equals x, all you have to do is take the conjugate and then rotate by 90 to the right. And you can see here that t of 1 is actually I, like it should be. So yay, sanity check. We could get fancier if you want. So you've got a problem kind of like that. A lot simpler. I think it's over a vertical line. Probably want to rotate some stuff, conjugate some stuff. Alrighty, friends. So that's all I got for you today. Let's just work today. I wanted to give you time to breathe. Well, breathe math, pure math gas in the air. And if you got that quiz back, and thank you, and you got that quiz back and you have a makeup problem, please get those to me by Friday at 2. And we'll probably keep doing that kind of makeup stuff on the quizzes. Does anybody need to talk? Yeah. Okay.
So one, I was just hoping if you like look at it, see if I was like on the right track. I probably should make that one less jokes, but
Okay, so 30 degrees, about the point 2. Yep. Cool.
I was feeling pretty good about it. It was just once I had to do that.
Yeah.
You just throw it in there.
I think this
Always
looks,
simplify it.
this, yeah.
Okay.
Let me just double check.
That's why I restarted in just a second, but let me try.
Wait,
I got the +2 because you get the -2 there, but then you got this +4 on the outside there. So it's like,
Yeah.
so it's like, you got this whole bit, and it's just going right in there. But you've got this 4 on the outside, so it's +4 -2. So it's +2, right? 'Cause it's.
yeah, but it's e to the I times pi over 6 times that too. Oh, I see,
Yeah,
wait,
because it's all inside
okay.
the parentheses. You see what I'm talking about?
I do see it, yeah, yeah.
It-
Oh,
it was
okay,
just-
I'm
it was
with you,
just like- It was
okay.
just like a tricky
Okay,
little bit.
got
I
it.
was like,
I think this looks good. I mean, test out a point.
Yeah. Okay.
Yeah, do a little test.
And then the other one that I was really, it just asked like what kind of a transformation. it
Yeah,
was, and I was
yeah.
like, that's all it does.
Is
It just,
point.
Yeah, and I would say rotation by what
okay.
and translation by what, and then that'll get it.
I don't know if I'm multi-taking.
Yeah.
And then this one asked me like if I knew it was unique, and I was like, I feel like it is, 'cause I don't know how else you can do that, but I don't know why I know that.
So the answer is no, it's not.
No.
So maybe you should think about that.
I was trying to I was just like, okay, I found one way to do it.
Yeah.
And I'm like, okay.
Can you find another?
Yeah. But I was like, this
I
is
think
how-
you
this
can.
is how it's like making it like.
Good, this is good. Oh, good, you're struggling with
Yeah.
this. Excellent. Excellent, that makes my day.
Okay.
Suffer away, my dear friend. Yeah. What else can I do for you?
Is this right? Just because this was different, because it's asking about the dilation. But I was like, in concept. it
Yeah,
makes
that
sense.
looks great.
Okay.
Mm-hmm. Yeah.
And then this one just took me a while, but does this look right for the
Mm-hmm.
look across the board?
Yeah, so, and then this you can actually simplify as well, right? I would turn that into a nice, complex number because it's really
Yeah.
quite a beautiful one.
Yeah.
But yeah, that's the.
Yeah, I was doing it late and I was like, this is like rough.
Yeah, so wait, so your shift, so what did you do? So
So
you
I
first
shifted by Y.
shifted, yep,
Okay, like,
perfect.
So I moved it by
Mhm.
K, and then I
Perfect.
said, I need to rotate it by 90 degrees so that it will turn. So
Yeah.
then when I flip it.
Yeah, perfect. Yeah, it looks great.
Yeah.
Yeah,
Okay.
looks good.
Alright.
Subtle. So you move to the origin, you rotate and you move back. That's beautiful. This looks great.
Okay, cool. And then
Yes.
for this, it's just more position.
No, that is composition.
Composition. Cool. Okay.
Yeah, with that melody you just sang with the composition. Yeah, just like that.
Awesome. I've been spending too much time with that one. I've been singing everything I've been saying lately.
It's, do you
It's
know
an elementary.
Wayne's World?
Yeah.
It's, I'm getting the Wayne's World vibe.
Oh, wow.
Hi.
I haven't
What's
done that in
going
a
on?
long time.
I was hoping to just like
Mhm.
look over
That looks
this.
great.
Okay, because I was looking at that and yep, I was trying to get like the geometric description of like.
And you
mapping
can once you,
over.
that'll be a little tougher.
I was looking at it and I was getting some really funky numbers and
Yeah. Yeah.
is that looking right?
Yeah, it looks great.
Okay.
Yeah.
And then for so 2 questions, and actually specifically with dilations.
it won't matter, because you would have the same formula for dilation or expansion.
Yeah, okay. That's
Or
what I-
contraction.
That's what I figured. So then for like 6, this was one I was a little unsure of. Where it's like asking for like multiple equations. Could I throw that in? Because then that'd be like.
There you go.
Okay, sweet.
Now you've got
That's what I
an infinite
figured.
number. That's right, that's
Yeah.
right, that is correct.
Sweet.
Yeah, well done.
Alright, and then number 7 with the reflection.
This is a lot.
I like was looking at it originally when it was saying like to reflect over a vertical line. It's like that can't be done over a vertical line. But I'm assuming I'd probably just use like the same process we did today where you like
Yes.
rotate and then.
And that is not it, but yes,
That's
you
what
are
I figured.
absolutely correct, yeah. You go to rotate, flip, then rotate back.
Oh yeah, sweet, I'll redo that.
Yeah.
But
Anything else?
I guess like, so for the geometric description, how do I go about finding that? Do I just like plug in points like we did?
I mean, I would just say, rotate, cause this could actually be made even prettier, right? You could just have this as 5/12Z.
Mhm.
So I would say rotate, counterclockwise by 5/12, whatever that is.
Yeah.
It's probably a pretty decent
Oh,
angle.
and then the rest of this is just.
And then the rest is just
translation.
translation, yeah, and then translate by this amount.
Okay, that makes more sense.
Yeah.
Sweet, awesome.
Good work.
Thank you.
You good?
Yeah.
Okay, I'll trust you.
So did you distribute this
Hi. Anything you wanna chat about? Okay?
Okay,
Okay, cool.
And then,
Okay, awesome.
So then what do you do with the
Howdy.
squared is just.
Right.
Got anything you wanna chat about?
yeah, I have a question. I didn't know how to use a loss function. I'm not sure what that is.
That's composition of functions. So that's T of S. So first do action S, which is whatever it is here. Do S and then take that result and do T to it.
Okay.
So yeah, let me write that on the board, cause I don't think, you're alone in that. What problem is that, Olivia?
3.114.
3.134. So you've got a problem where they give you a couple translations or a couple transformations and they ask you to find this. This is the composition of those functions. So first run through Z. So for example, if T of Z was, I'm making my life real easy here. If T of Z was that and S of Z was -5Z plus 1, then the thing they are asking me to find here is T of S of Z, which is 3, plug in the S, and then simplify out. That's what, does that make sense? Cool. How are you, can I help here? You all good?
Yeah, we're like at the same.
That looks good.
Just looking gross.
Well, so the way I would organize it is, it's just gonna be E to something I times Z. So just put that E to whatever Z by itself, and that basically says do a rotation. And then put everything else as a constant to the right. So it'll be rotate by whatever pi over 6 plus pi over 4 is, and translate by, and you could just say it, it's gonna be a nasty number. Translate by this weird ass number.
Okay, is it, and I'm just like conceptually thinking about, but I'm like this, is it rotating at 75 degrees? Or not?
Not necessarily, because there's a translation also. So you would be right if there was no shifting,
But let's, so for example, here, something I can write on, sorry, I'm cramming this jelly beans in my mouth. Oh, I can write on here. Yeah. So one of them is rotate by 30 around 2. So here's 2. So let's say here's Z, and I rotate that by, let's say 30 degrees around 2.
Oh, so it's not this.
Yeah, exactly. It's around 2. And you've got the formula for it. That's perfect. But that is the formula for doing what I just did here by 30 degrees. Yeah. So you can see how this is a little bit different, right? And then S is take that result and rotate it by 45 degrees around 4. So now we take that thing and rotate it more, 45 degrees around 4. So it's yeah.
It's
It's
weird that.
weird, yes.
Okay, that makes sense. This picture did not help.
That is not, yes, that picture is befouling your thought process.
Dr. T.
Hi.
People are like, it's kind of weird.
Mm-hmm.
This was like.
Where's your S formula? Can you write it separate though? Because I think that's gonna help, because that is, you're kind of missing something. Yep, that's not quite right. Because, and this one is actually not quite right either. Because what you're doing, let me show you what you're doing. You're taking Z, you're rotating it by pi over 6 around the origin. That's not what we're supposed to do. We're rotating around the point 2. So do what I was doing at the beginning, which you might not have been here for. Yeah, you need to rotate around 2. So your first thing is to shift everything to the origin, then rotate, then shift back. So that's what's up. So these aren't correct here. Yeah. Good.
Yeah.
All right.
Oh, yeah, just trying to get my vocabulary together.
Ooh, I like that. What a great goal. Anything to chat about? You good? Okay, that's cool. That's good.
I mean, so when you should from 2 to like, would it be just media?
Mm-hmm. Yeah.
So, so it would be this one times. Anyway, but like this one is like rotating, 30 degrees, but, we wanted to rotate the shifts from 2 to.
Yes. So you shift left by 2, rotate, and then shift back.
So with these, say -2.
Yes. Yeah, that would be your left shift, and then that whole quantity times that number.
At the origin, but you have to shift back.
Yeah, and then take that whole result and add 2 to it, and that'll get you back. Yeah. Is that, yeah? Yeah, it's kind of cool. I like thinking like that in those little steps.